Hello and welcome. In today's video, we'll talk about collecting memory dumps. I'll show you different ways in which you can collect memory dumps, mainly for the post-mortem debugging purpose. Before you go on to this video, I would highly recommend you to watch my Windows debugging fundamentals video. I'll provide the link in the description below. Types of dump. There are two types of dumps mainly: mini dump and full dump. So as you can tell from the name itself, mini dumps are smaller than full dump. In a mini dump, you mainly have the process and module information, the call stack at the time of the crash or the time when the dump was taken, and you have the call stack of all the threads in the process, and registry data. The full dump, which is also known as a mini dump with full memory, typically called full dump most of the time, it includes all the mini dump details plus full memory data. It includes the handle data. It includes the information about unloaded modules, basic memory information, thread time information, and many more. When I work with dump, I almost always prefer to take a full dump because many times when we work with mini dump, you will find that it doesn't contain the data that you're looking for, and then you need to go back and collect a full dump again. Rather, I prefer working with a full dump. Now, before you start taking memory dump, there is one last thing that I think you should know, which is types of exception. There are two types of exception in Windows world: first chance and the second chance. When you take a memory dump for some exception or a crash, you need to understand the difference between first chance and the second chance exception. So when an exception occurs in a process that you are debugging, the system first notifies the debugger by passing the exception information to it. This is known as first chance notification or first chance exception. If the debugger doesn't handle the exception, the system attempts to locate an appropriate exception handler that can handle it. If the system cannot locate the appropriate handler, the system once again notifies the debugger that an exception has occurred. This is known as last chance notification or a second chance exception. If the debugger does not handle the exception even this time, the system terminates the process that is being debugged. Now, let me try to explain it in a different way. Let's say, for example, you have a .NET application where you have written some code in a try-catch block. And in that block, an exception is being thrown. So as soon as the exception occurs, if the process is being debugged, it will first try to notify the debugger. It may be WinDBG, it may be Visual Studio, or whatever debugger is attached to it. It will try to notify the debugger saying, hey, an exception has occurred. Do you want to do something about it? The debugger, based on how it is configured, may do something about it. Maybe it will take a dump or do something else, or may ignore it. If it is ignored, next it looks for a exception handler. So it will go to the try-catch block. If there is a proper try-catch block, the exception will be handled inside the try-catch block, and maybe it will show a message box or log there or do something. If there is no handler, it again goes back to the debugger as a second chance exception, saying, hey, there is no one to handle my first chance exception, so I have come to you again. Now, the debugger will decide if it has to do anything about it. It may again, based on its settings and configurations, choose to do something with the second chance exception, or may again ignore it. If it is ignored again, the process doesn't know what else to do now. So it will crash. So that is basically the difference between a first chance and the second chance exception. I hope it is clear to you. Otherwise, please leave your comment. I'll try to explain you in some other way. Now, with that out of the way, let's talk about different ways to take a memory dump. Now, there are so many different ways to take a memory dump for both kernel mode dump, user mode dump, maybe it's in Windows or in Linux. So I'll not be able to touch base on all of them. So I will just try to explain maybe 5 or 6 which are my favorite, and that should take care of all your scenarios as well. So let's start with Procdump. Let's first go to the download site. You can search Procdump in any of your search engine, and this will be the first link that it will show. So Procdump is available both on Windows as well as Linux. You can download it from here. It is not an installer, it's just a zip file that it downloads. You need to Xcopy it to a path of your convenience. Once you do that, you can run it from command prompt, from an elevated command prompt, and then you can just follow this document to see what are the options available, and depending on your specific scenario, you can use those commands to take your dump. Procdump has a lot of switches or parameters through which you can take your memory dump exactly at the time that you need. For example, if you see here, there's a switch for memory commit. Um, so you can create a dump based on the memory consumption of your application. Similarly, you can take dump based on CPU consumption of your application. For example, if you want to take a dump when the CPU consumption of your application goes beyond a certain threshold, you can configure Procdump in such a way that it takes the dump um, based on the CPU consumption of your application. For example, if you see here, this writes 3 dumps at an interval of 5 seconds when the CPU consumption goes above 20%. Right? So once the CPU consumption goes above 20%, it will take a dump, wait for 5 seconds, take another dump, wait for 5 seconds, take another dump. So if you go through the document, you'll see that it gives you a lot of flexibility on when and under what circumstances you want to create the memory dump. And that is one of the reasons why Procdump is my favorite tool when it comes to taking a memory dump. One thing you need to remember is it is extremely important that you take the dump at the right time in the right way. Otherwise, the dump file may not be of any use. I work in so many scenarios where people come to me with a memory dump, and when I open it, I realize that it was not taken at the right time. And so I had to ask them to go back and collect the same dump again. For example, if I'm facing a crash, what sometimes people do is they will just say MA and the process ID, let's say it's 1234. Now, I have come across scenarios where people are seeing an exception being thrown, and when the exception is being thrown, they take the dump in this way. So this command will basically take a full memory dump at the time when you run this command. But what happens is by the time you run the command, the stack has changed in the application. And so that would not be useful for me to understand what might have caused the exception. So again, it is very important that you take the dump at the right way. If it's a crash dump, take it the right way. If it's a hang dump, take it the right way. Um, and that would really help. I have a sample application created to create a memory dump, and I will show you a demo how I create the memory dump. For example, in this folder, I have um, procdump.exe, procdump64a.exe, and ual.txt. So I'm going to run procdump. Um, but before that, let me go here and run my demo application, which is a crash demo. Okay, so you already know about first chance and second chance exception. So if I enter 1, it will throw a first chance exception. If I enter anything else, it will throw a second chance exception. So now if you see, the process is already running. The name of the process is crash demo. And if I go to the task manager, I will see this name along with the PID, the process ID in the task manager. So I come here and say minus MA. So if you go to that link, and I'll put that link in the description section as well, minus MA means full memory access. So it's a full dump. And I want to take it for first chance exception. So what it basically means is if an exception is thrown in your code, which is very much expected, and you also have a catch block for that exception, even in that case, it will create a dump on that exception. So how do I mention first chance exception? I will say minus E and 1. 1 stands for first chance. Followed by, there are a lot of other parameters that I use time to time, like minus F if I know the exception is um, argument exception. I can just say minus F argument. So is there's a argument null exception or any kind of argument exception, even if it's first chance, um, I can mention argument. So first chance exception is very common in an application. It happens all the time, and there is nothing wrong about it because all those exceptions are getting handled and you are doing the appropriate thing based on that. So in many large applications, if you try to take a first chance exception, it might create an exception before it even reaches the point that you want to debug, right? Or if you use minus n switch, it might create many dumps. So in that case, what we do is we use filter dump. That means you mention the specific exception for which you need to take a dump. So for any other first chance exception, it will simply ignore it. Only for that specific type of exception, it will take a memory dump. But for now, I'm not going into this. And at the end, I need to mention the PID. I can get it from the task manager. If it's like, for example, 1, 2, 3, 4. But in this case, I am just using the name of the application, which is crash demo. Right? As soon as I hit enter, it says it is monitoring the process, right? So it's monitoring the process. There is no first chance exception happened yet. So it's at the moment it has not created any dump. And here I'm creating the first chance exception by putting 1 and hitting enter. So as you can see, once I did that, it has thrown a system.exception. And now let's see what happened to our Procdump. So it has created a dump file in the same location from where we are running the Procdump. So if I do a dir, you'll see this dump is created, right? So it has created the dump. This process is still running. It has not crashed. I hit enter to gracefully exit the process. Now let's see an example of second chance exception. I'll run the same application again, and I'll also run this procdump command, but for second chance. So I will remove 1. So minus E1 means first chance, only minus E means second chance. So if you see, now so I'm running this command. Now this command is waiting for a second chance exception to happen, and then it will take a memory dump. Now here, what if I generate a first chance exception? If I come here, it logs the exception. It knows that an exception has happened, but it has not creating a dump because it is waiting for the crash to happen or the second chance exception to happen. Only then it will create the dump. One thing to remember is if the application exists or exits like this, gracefully exits, um, the debugger will automatically detach itself and it says dump count not reached. So it has not created any dump. So now let's do a dump for second chance exception. I first come here and I run this application and I am running the procdump command for second chance exception or crash, no 1 after E. So I'm looking for a crash. If I come here and hit enter 2 and hit enter, as you can see, it has crashed the application. If you see, I have returned to the command prompt. That means the process has exited, right? So if you go to the task manager now, you will not see this process name or this process ID running. So the process has crashed, second chance exception. If I go back to the command prompt, I see it has created a dump for the second chance exception. So this is the second one. Sorry, this is the first one, this is the second one. So that was a quick demo of Procdump. Similarly, we have another tool called Debug Diag, which is a Windows only tool. It's not available in Linux. It is a very popular tool. I'm not going into details about how to collect memory dump using each tools because then it will be a very long video. And there are ample documentations and videos available in the net about most of these tools, how to create a memory dump using these tools. But still, if you cannot find any good video of taking a memory dump using any tool, you can just let me know in the comment and I will try to create a video for that specific tool or scenario. So Debug Diag is a GUI tool. It's not a command line tool, though it can be used from command line as well. Then we have WER. So this is a tool that is built in Windows. You don't need to install anything. It comes with the Windows. And this is a very useful tool for some specific scenario. I generally use it specifically for crash scenarios. When the crash is very intermittent, like I face a lot of issues where the crash happens in the production like once in a week or once in a day. And it's very difficult to keep your Procdump or debug diag running all through the day to catch that specific crash, right? So in that case, you can just use the Windows error reporting, WER, to um, configure your system to create a crash dump when the specific process crashes. For example, this is the link through which you can configure it. I'll put this link in the description below. So it's very simple. You first of all need to go to either this registry location if you want to do it for the entire system, but if you want to create dump for a specific application, use this registry path. So you need to replace my application with your application name. So you need to create a registry with this name in this specific path. And then you need to configure these 4 parameters. The last one you can ignore for now because that's an advanced option. But otherwise, the dump folder is really the folder that you want to create the dumps in. So if you see here, it is um, a reg word that you need to create, and then dump count, how many dumps you want to create, and dump type. So again, custom dump is the advanced one. You don't need to know about it right now. Ignore it. But otherwise, you know what is a mini dump and full dump if you are watching this video from the beginning, right? So based on that, you need to set the parameters in your registry, and that's it. Once the crash happens, it will create the um, dump based on your requirement. So the next is dotnet-dump or dotnet-gcdump. These are command line tools that comes with .NET SDK that allows you to create memory dump on Windows as well as on Linux. This comes with .NET Core, not with the .NET framework. Then one drawback for this is that you need to install the SDK to use this tool. If you have only the runtime installed, these tools are not available. For example, in scenarios where you are running your application from a container, sometimes you don't want to install the full SDK in your container, right? Because you want to keep it as lightweight as possible. In those scenarios, you can use another tool called CreateDump that is a part of .NET Runtime. So if you have .NET Runtime on a system or on a container, then you have CreateDump. However, you can also use Procdump in Linux to create memory dumps. And last but very useful is tttrace. So a memory dump is like a snapshot of the memory at that specific time. That specific moment of time, it's like taking a picture of your memory, right? So if you consider the dump as a picture of the memory, then tttrace or time travel trace as we call it is a video. So it creates a dump for a frame of time. You can run it for 30 seconds and but you need to keep in mind that it will create huge file because obviously it's running for a while. So we need to try to run the TT tracer and reproduce the issue as fast as possible and stop the tracer. It is an advanced option, so I'm not including that in this video. But if anyone is really interested in knowing how to take TT trace and how to analyze TT trace, let me know in comment section. If I at least get 10 requests, I will create a video based on that. You might be wondering, why do I even need a TT tracer? So I'll give you some example. For example, I was working on an issue where the application was throwing access violation. And when I took a normal memory dump, I found out that the application was trying to access a memory which was corrupted. Now, this corruption might have happened a couple of seconds back or a couple of minutes back, but we didn't know or didn't face the issue because it was not trying to read that corrupt memory. But now that it tried to read that memory, it is throwing an exception. So in this case, I need to know what might has happened in the past which has corrupted the memory. In these scenarios, sometimes we take dumps with some G flags. I'll not talk about that in this video, but the other option is to take a time travel trace. So when I took the time travel trace, I found out that there was another thread which was coming and corrupting this memory a while back. And after some time, when this specific thread was trying to access that memory, it was throwing an access violation. So this thread was just a victim of another thread. Similarly, I was working on a case where when the application was throwing a null exception, though it was a handle exception, it was getting handled in the catch section. Still, whenever it throws that null exception, ultimately after a while, when the application tries to create a SQL connection, the connection always fails. Now, to understand what is the relation between that null reference exception and the connection failure, we need to understand the entire things that happened in the memory during that time. So for this kind of scenario, we need a time travel trace. For TT Tracer, there are tools available, but you can also take a TT trace through your WinDBG. The new WinDBG that you download from your marketplace that allows you to attach itself to a process, and then you can run the process for a while, and it will create the run file and the out file, which are basically the output file of a TT trace. Like for a dump, it's generally .dmp. Similar for TT trace, it's generally .run and .out. Thank you so much for watching the video. Let me know in comments what would you like me to create the next video on, and I will create that for you. Thank you once again. Bye bye.